Welcome to Cloud Realities Live, a conversation show exploring the practical and exciting alternate realities that could be unleashed through cloud-driven transformation. I'm Dave Chapman.
I'm Sjoukje.
And I'm Rob Kernahan.
And this week, we are in Barcelona for the Mobile World Congress 2024, or hashtag MWC24, I think, online.
Yeah.
And it's the first time at this conference for us individually and us as a show.
It is.
And I think overwhelmed might be the word I'm thinking.
It's massive.
It is.
Huge booths. I've never seen so many huge booths.
This is obviously the conference of conferences.
It feels like of the conference pyramid. This one might be the top of the conference pyramid.
Apart from CES, maybe.
I think
Consumer
CES,
electronics.
Yeah, exactly. I think it's probably the only one that's as big as this. It feels like, at least the ones we've been to with this thing. And to give you a sense of it, the marketplace floors at things like reInvent and Google Next, they're big. And you have one giant room with a bunch of stalls in and of varying different sizes and configurations. At this one, I think there are 4 halls of marketplace. Is that right? Rob, you went for a walk around a couple of them today, trying to find the booth.
I was in Hall 3 for quite some time, Dave.
Yeah.
Based on your information, looking for our booth, and I couldn't find it. And then I had to ring you. And then I discovered you'd actually given me the wrong hall number.
We're in Hall 2.
20 minutes later, I managed to find it. It's funny, that, isn't it? I was getting quite confused, though, walking around going, how hard can it be to find a big, massive booth? But it turns out, when you're in the wrong hall...
Quite hard.
Quite hard, yeah.
Yeah. And actually, the booths are like multi-story, kind of quite large footprint things. So you can't even sort of gaze across the marketplaces.
They're all really
You're
high.
Basically just seeing like a lot of real estate. Sjoukje, what's your first impressions?
Yeah, that it is massive. And I see lots of people in suits.
Slightly different
there is
vibe,
a suit
innit?
level.
Different
Yeah,
vibe.
yeah,
Different
yeah.
vibe to the cloud conferences.
Yeah, cloud conferences.
Very different,
There's
yeah.
more sandals, I think, at a cloud conference.
Yes.
Or Crocs.
or Crocs. Yeah, decent amount of Crocs.
Or branded sneakers.
Branded. Oh, yes, they all had branded sneakers last year, didn't they?
That was a thing at reInvent last year.
That was a really thing.
So we'll keep our eye out for that. So we're going to bring you our kind of evolving views on what MWC is like, the big threads of the show, and we're going to talk about the 6 topic areas across our 6 shows, just to give you a sense of what they are. It's 5G and beyond, connected everything, humanizing IT, manufacturing DX, which we assume is digital experience, game changers, and our digital DNA. So in each of the episodes across the week today, this week, we're going to take one of those themes, and we're lucky enough to have a guest join us, or 2 guests to join us to talk about one of those themes that's specific to what they or their organization are doing. So we're looking forward to that. On today's episode, we're going to do connecting everything. So to give you a sense of what that actually means and what the show is trying to do with that thread, that according to GSMA Intelligence, by 2030, there'll be 6.3 billion unique mobile subscribers globally, with 5 billion global 5G connections. The industry is truly connecting everyone, but with a number of connected IoT devices set to reach over 15 billion in 2 years, connecting everything requires network solutions that are open, seamless, sustainable, and secure, and a growing mobile ecosystem that needs to work together from the cloud and cloud hyperscalers all the way through to tower, fiber companies, and satellite providers. So like an enormous sort of ecosystem of connection.
It's all converging as well, isn't it? So as it all comes, I had to get it in, didn't I? I had to get
Rob,
that one in.
We're 5 minutes into the first
You say
episode.
converged. Yeah. But it is literally meshing together of all the technologies to create new, exciting solutions.
And architectural plays across that.
Yeah.
So rather than it just being, hey, one big sort of centralized thing up in the cloud that's connected in a relatively rudimentary way, this is almost like everything connected in every direction.
Yeah, absolutely. And there's a mass complexity in how that's managed.
Yeah.
And so we see the rise of everything as software. So we heard software will eat the world a decade ago.
Yeah.
And I think this is now the maturity curve and the realization of as that comes together, you can now manage this incredible complexity
That's
much
right.
more easily.
So we've got a lot of threads to try and pull together across the week, and I'm delighted to say that joining us in today's show, we have 2 great guests. First of all, to talk about intelligent edge and the potential of 5G networks, we've got Muneyb Minhazuddin, VP and GM for Network and Edge at Intel. And then following Muneyb, we've got Anand Chandrasikher, the founder and CEO of Aira Networks. But first of all, we've got Muneyb. Muneyb, thank you for joining us today.
Hey, thanks for having me on the show.
Now, how's your conference been so far?
Busy. I started at 8. I've been going back to back, so it's that
Whatever
kind
you
of
do,
a show.
don't fall asleep on the podcast.
No.
Rob did that once.
All right, if I start snoring, wake me up.
Rob has mastered falling asleep in the office with his eyes open, like cowboys.
Oh, wow. Nice. Yeah.
Keep an eye on the cattle,
Yeah.
Yeah.
Somebody
Anyway.
might actually believe that, Dave. That's the worrying thing.
I keep saying it
Half the
often
course,
enough, Rob. Yeah, so how's your day been?
Busy. A lot of partners. At 6 a.m. we launched a platform this morning, and an Edge AI platform from Intel. So that's very exciting.
Well,
And,
we'll
yeah.
certainly dig into that in a
course,
little while,
of
I think.
course, yeah.
But before we get in, why don't you just tell everybody about yourself and your role?
Sure. I lead at Intel, the Network and Edge business unit. I lead all of the software portfolio. So I'm the general manager for all the software at Network and Edge.
Amazing. So you can certainly help us try and pick our way through connecting everything as a topic.
Oh, absolutely. Yeah.
Fabulous. So look, let's dig in and let's talk about where we are with Edge generally. So Edge has been something that we've probably been talking about in different languages, like we've called it things like fog computing historically and low-lying cloud, and then of course there's a preponderance of devices now around the edge that are getting more and more intelligent over time. So as somebody who lives and breathes it every day, what's your take on where we are with Edge? I was going to say the cutting edge of Edge, but that's probably a bit too far.
Living on the edge.
Living on the edge, exactly.
There you go. Yeah.
So what's it like
Now we
living
got
on
to
the
play
edge
the
right
song.
now?
Where's the song? Please.
We'll break into song a bit of Bon Jovi in the background.
I would say
Aerosmith.
Oh my God, I
Aerosmith.
can't believe
I
I
was
got that
going to say, come on.
Sorry.
Okay.
Yeah.
I would. Edge has been around, and it's not anything new. I would say early days. You would say that was remote office, branch office,
Right,
Or
right.
I think was home office, branch office. Whatever, hobo. I didn't want to go there. Home office. It existed, and largely was trying to deliver corporate capabilities at the remote branches and stuff like that, right? So the evolution is over decades of, hey, we had this infrastructure, blah, and everything was centered around call it client-server architecture, and it was like, oh, you got servers somewhere, and then I got clients that are accessing that,
Right.
and evolved into, well, I would say cloud came about, and then it's just the edges are starting to become mobile devices and everything else because you got connectivity everywhere, and cloud is super compute. So there's been an interesting evolution of what that form factor is. In parallel was, hey, I got IoT, digitization at the edge. So a lot of cloud out and then edge in innovation happening. But also innovation around different areas. Innovation on application delivery, platforms, mobile phones, IoT devices, all
Right.
types of,
Right.
innovation. I call it edge in, connectivity, different types of G.
Hyper growth of that type of device over the course
Exactly.
of the last 5 years.
And I think the pendulum swing happens where you go to distributed computing, centralized computing,
Yeah, right.
distributed again. Every time that pendulum swing happens, there's more and more innovation.
Yeah,
So
yeah.
the new edge, where are we today?
Yeah.
I believe there has been explosion. Like there's been always the pendulum swing. There's a lot of data that gets generated. I would say in the last few years, first as we all got hit by COVID.
Right.
So
Yeah.
everybody moved and worked from home. Suddenly all, central offices are empty and everybody's home networks are getting, saturated. So how do you re-provision? So I live in Palo Alto in the Bay Area, which has got big campuses like, Meta, Google, everything. Massive offices with 30,000 employees kind of infrastructure, huge pipes,
Right.
now doing diddly squat. Now,
Sure.
I live in the area, and first few weeks was a really bad connection because they didn't expect me, my wife, my 2 kids all to be connected daytime.
Right.
So everything got re-provisioned. So what I'm getting at, this edge evolved over the last 4 or 5 years where employees started to work remotely. Then you had businesses, retail, manufacturing, et cetera, going through. Now suddenly retail's going, I wish a pipeline dream of curbside pickup because I was like, why would I do that? I drove all the way to the store. I'm just going to get in and pick it up.
Right.
But now curbside pickup became a financial viability for the retailers.
Yeah.
Because if they didn't provide that in social distancing, they're shut down as a business.
Yeah, that's right.
So it's such innovations push people over the edge.
Yeah.
I'm sorry.
You can't help yourself.
I can overloading all these terms, but to innovate at the edge, manufacturing is like less people, like almost 43% of manufacturing employees didn't show up, which means they had to start driving automation.
Right.
So, and then transportation, logistics, they went to 3x capacity because now everybody was ordering milk and bread and eggs online through these things. So the phenomenal last few years of innovation and the amount of workload starting from people moving to processes moving to the edge has exploded, where it was not anymore just customer records or remote access of central office. There was a lot of workloads happening at the edge.
And then across that, workload shift, you've also got the promise of 5G.
Of course. Yeah.
And what does, it might seem relatively obvious, but what does 5G really bring to it? As somebody who's kind of frankly used 5G and it, feels to run slower than 4G most of the time, certainly in the UK anyway. Yeah. So ultimately, what's the promise of that?
I believe, as of course, going from different generation, like as I've been there with 2G, 3G, 4G, 5G. I think it was the push has been largely about better connectivity, faster speed, better consumerish information. 5G starts getting into the realm of enterprise-like application overlays on top of connectivity. So why? But I guess the technology itself was set up for providing and dividing and slicing and giving different quality of service levels to different types of services, etc.
Right.
So it leans itself to say I can go beyond just one. You've got a lot of content. How many hours do you spend on TikTok every day? You got content.
How many hours?
I plead the fifth.
But, cloud gaming, all of that. So there's content delivery from a consumer perspective, but also the technology leans itself to trying to drive different types of security envelopes and things like that. Again, because I picked up on the COVID thread, I'll give you an example there. Is like, I got to have, COVID shots taken in a tent in a parking lot.
Right.
Or checks, or because that's what's happening.
Yeah.
Well, suddenly my electronic medical records are coming on a 5G network delivered. How secure is that?
Yeah, right.
Because you go through all kinds of regulations on delivery of electronic medical records. But now it's traversing that. Can I take a slice of that? Can I secure it? Can I give it all the healthcare requirements on data privacy and everything else? Can you do that? Not possible, right? So you suddenly start manifesting new types of business requirements, security, data sovereignty issues, and apply it. You couldn't do it just on a bigger and fatter pie.
Yeah, right.
You needed more smarter technology to get there. And
well, is there another point in there? I know it's not directly the point you're making, but is there an aspect here that intelligent edge devices also, help resolve the latency problem that exists with the cloud? So you can have architectures now that are sort of staged across the sort of main hyperscaler clouds as well as then on the edge. How does that pan out for you, do you think?
Yeah, I would say an edge is broad terms. So you could start from your data center or core or go to the cloud. From the cloud, and there's multiple kind of glossary terms around this. Near edge, far device, etc. It's the proximity to the user.
Right.
And what's getting smart, what are the aggregation points, right? And we were expressing like donuts. Donuts where in the middle is the cloud, and as you move closer to the edge of the donuts, there's multiple aspects of aggregation and distribution.
This sounds like the Homer Simpson architectural approach. He likes a donut, doesn't he?
Oh, yeah, of course he does.
Coin that as well, but the donut is more capable all the way to the edge, isn't it?
Right.
So that's the thing, isn't it? When it used to be the core that was intelligent and the edge was a bit simpler.
Yes.
Now you can have inference at the edge and quite heavy lifting from a processing perspective. So this mass distribution of compute is occurring as well at the same time. So we have a lot of software at the edge. It's not just collecting data; it's now processing it as well.
Yeah. So when we have the type of architectures we've been talking about with this massive explosion of intelligent devices at the edge, what kind of management platforms do you need for that situation?
I think the big, there's several. you got to think about how do I distribute infrastructure effectively at the edge. Right now, usually cloud and data center like technologies, they are more concentrated on managing 100 data centers,
Right.
200 regions or zones, but highly dense.
Yeah.
Because they'll have hundreds of thousands of workloads.
Right.
Whereas if you flip it to the edge now, you're talking about hundreds of thousands or millions of edges, but very light workload types. So you flip the infrastructure management and distribution, call it fleet management of this,
Right.
doesn't come out of the blue. It has to scale in a very different level.
Right. Yeah.
Then how do you do application distribution where, again, these heavy data centers in cloud are set up for massive, call it ephemeral shrinking and growing of infrastructure, whereas, intelligent edge is very fixed.
Right.
You either have a mobile phone or a device or you don't. It's not ephemeral. You suddenly don't do hopping. Connectivity, like you brought up before, if I'm, traffic flowing through my LAN in a data center or within a cloud, no big deal. Whereas at the edge, you're struggling to get to the last mile. Right. So the latency. So all those factors, call it very simplistically, what I articulated was compute, network storage, manageability, and security. The last but not the least, because all your assets in a data center cloud are behind massive firewalls, physical security locations, etc. At the edge, it's completely zero trust.
Right.
Like everybody accesses that. So along those 5 parameters, how do you go and manage the edge extensively? The intelligent piece is going, now these devices, how much can you offload to the device itself? How do you onboard it securely? How do you then, run data? And what ends up happening, a major last factor is data management.
Right.
All this data being created, does it get processed at the edge itself, or all that massive data gets shoveled back up to the cloud, where the trigger of the data management is basically a simple outcome?
And depending on how well you're connected, you can change those patterns as well, I'm assuming. So if you've got a really strong, good connection, then you might want to shift it. If not, and you have intermittent connectivity, more processing the edge can help a lot, can't it?
Yeah, what you're talking about is, and it's a difficult problem, I would call workload placement.
Yeah.
Where do I place my workload? And, again, having a healthy conversation over here, every vendor is biased on placing where to place a workload. I.e., if I place it in the cloud, I'm going to make my most money as a hyperscaler.
Yeah.
If I place it in a data center, I'm going to make most money in that managed hosted data center. If I'm going to place it at the telco edge, I'm going to make most money on my connectivity. So everybody has a biased view of where to place it, but ideally you want an unbiased view of saying, I want to place the workload where it delivers the best app service level objective, SLO. And that could be and it's not a fixed, it has to be dynamic. Like you just were pointing out, it's like I can move it closer to the edge when there's huge traffic and a lot of data. I don't want to have the bandwidth to do it. Or if it's just back-end process, I can take it back to the cloud. So dynamic workload placement between the core, the data center, the cloud, the edge becomes an interesting problem to have.
And that is a new paradigm for computing. It requires a different way of thinking, a different type of software approach. It requires different teams to work. It's quite a big change considering what we've been used to, where everything's been more centralized. Do you think organizations are starting to get a grip of the change now? Because it feels like the mastery and the maturity is occurring.
Yeah, it's still early days, right? Again, I was kind of, laying Easter eggs along the way, like client-server architecture. I'm old enough now to claim, right? So when I'm writing the application, when I was writing, I had to do socket programming. When I'm defining, my IT already had all the infrastructure in place, and they said, "Well, is your app a TCP socket or a UDP socket?" "Oh, you mean I got to hard code it?" "Yeah, you got to hard code it." I was like, "Okay, I'll code my application for that."
Yeah.
Basically, it was pre-designed for a client-server architecture.
Yeah.
When you get into cloud computing, the problem is like, "Oh no, don't worry about all of that. I got all the infrastructure covered. It's all ephemeral, but it's homogeneous environment. I scale up and scale down as long as it's my fixed compute network storage platform that I run. Not your problem." In both those instances, the applications were defined around a compute fabric.
Yeah.
Wherever there have compute, server has the most compute, client's lightweight compute. Processing will happen there, so I got to connect to that. Cloud, don't worry about it. But you just need to collect to the cloud. The whole thing is around, ephemeral compute. When you come to the edge, an edge native, it's actually the application model itself needs to switch over from
needs to move around
because it's not around centers of compute pools. It actually have to change the app fabric to be more on a network fabric because connectivity becomes more important And then you could have a lightweight compute, highly distributed, but the app model needs to shift towards a network fabric model rather than a compute-centric model.
Right.
And it's a fundamental shift.
Yeah.
Very significant. Very significant. Intel made an announcement this morning, I think. Do you want to tell us a little bit about that?
Oh yeah, excited! It's my baby.
Yeah.
Right. So we launched our edge native AI platform today, this morning, with a whole bunch of partners.
Edge native AI.
AI
To
platforms.
educate us a little bit on.
Yeah. So
Concept.
so the concept being, hey, you need a software platform. We've been talking about software, right? So to deliver infrastructure, applications, and AI models to the edge.
Right.
In a day 0, day 1, day 2 kind of format. So infrastructure, how do you securely onboard in a zero trust environment, and then provision with zero touch, and then do telemetry, remote, break fix in that. Application, how do you build applications, usually built in the cloud or somewhere, distributed effectively to the, orchestrated at the edge,
Right.
and then observe them at the edge to fix it. And third, AI model building and optimization, but also distributing AI models to the edge, orchestrating them, and observing them and lifecycling them. Has been 3 different user types. IT doing the first part, DevOps doing the second part of the application, and data scientists trying to build AI models.
Right.
We've converging them all 3 into one single platform. So you can actually, the cool thing is, do I get AI built by 100,000 AI data scientists, or do I infuse building AI and distributing AI to the 25 million plus app developers?
Right.
So this platform actually infuses to the 2 workflows.
And does it run over multiple clouds? How
Absolutely.
architecturally, is it like a layer? How does it actually function?
So a partnership announcements wherewith, because again, this it was funny when you're talking about converging of all of these different things, right?
Right.
So at the edge, we see the convergence of hyperscalers, because you've got services in the cloud they want to push to the edge. Telcos, of course, who have the last mile coverage. You have OEMs who have all the hardware. And then you have ISVs who are building the applications themselves, and OSVs who have different operating systems, right? So it's a convergence of a whole set of, call it cloud out providers, then to these actual edge-in device providers like OT providers.
Right.
So at the announcement, we announced our partnerships on the CSP side with both AWS and Microsoft Azure. OEMs, starting with Lenovo at the booth, there's demonstrating our software with their integration.
Cool.
ISVs, a small company called SAP, right? Partner joint solution.
What do they do again?
So SAP HANA distributed to all different industry verticals, but at the edge through this platform.
Right.
Then telcos, of course, we're in a telco show. Verizon delivering that, along with Red Hat, who's an OSV.
Right.
And then a whole range of system integrators, ranging from Accenture, Capgemini, Wipro, LTTS, who'll deliver the solution to market.
You must have been working on this. I mean, given that level of...
That's a lot of orchestration, isn't it, to get all that together?
Yeah.
So how long have you been working on that announcement?
I've been looking at the edge for 4 years,
Wow.
but Intel for the last year.
Well, congratulations on that.
Thank you.
Congratulations on that. And thanks again for making some time to come talk with us today.
Absolutely.
And we end every episode of the podcast by asking our guests what they're excited about doing next. And let's say maybe excited about doing in Barcelona next. So that could be something that's just fun, or it could be something in your professional life. So what are you excited about doing next?
Oh, I'm back here in summer. So my daughter got scouted by, my younger daughter, 13 years old, got scouted by FC Barcelona last summer.
No.
That is
We were here
ace.
in November, and they've invited her back to represent them for under 14 international girls tournament.
Congratulations.
That is
That's
ace.
Congratulations.
significant. That's very significant. That might be one of the best answers we've had to that question.
I think that's up there, isn't it? At the top, isn't it?
That's a real cracker. I'm delighted to say that I'm joined by Anand Chandrasikher, founder and chief executive of Aira Networks. Anand, how are you?
Thank you, Dave. Very welcome to be here. Thank you for having me.
Oh, we're delighted to see you. Thanks for making the time. How's your conference been so far?
Great. It's been a very busy conference for us. We've been chock-a-block top to bottom. which is what one would hope when you come to a conference like this.
Ideal,
So it's been
wouldn't it?
great. Yeah.
And is this your first MWC? Or are you an old hand at this?
Veteran. You look like a veteran,
Yeah,
can I
look-
say? You've probably
yeah.
been here a number of these.
I don't like the term veteran particularly, but I have been here multiple times.
Right.
In my capacity as founder and CEO of Aira, this is my second time around.
Right.
We were in stealth last year, until last year. Last year was the first show that we actually showed our products, and this is our second year.
And what observations would you make about MWC over the years? Because what really surprised us, this is our first one as a show, but also as
Yeah.
individuals. And what really surprised us was that it's much more than a telecom show. It's like a full-on tech, exploration as much as it is a telecom show.
That's exactly right.
Yeah.
It is a full-on tech and exploration of tech, which should not be entirely surprising, because if you think about two of the things that improve productivity of mankind, right? Transportation is one of them, communication is the other one.
Right.
So you would expect the show that is focused on communications to talk about all walks of how it might improve our productivity and lives, etc.
There was an interesting article in the magazine they have here. They do a publication just for this event, and it was talking about diversification of revenue and telco becoming the digital telco. And we see a lot in other organizations, in other sectors, business pivots. They happen a lot, and it appears to be this is starting to show that pivot occurring with all the other vendors and organizations and GSIs arriving. And I think it now said 26% of telco revenue is from diversified streams, so not about communication. So they're starting to build, which is a really interesting thing, and the growth line is trending up as well. So it's a big change occurring, which they defined as being a digital telco as opposed to just...
Yeah.
Which I thought was quite an interesting point, that we're at an inflection in the industry.
Completely. And when you think about communications, you initially think about voice.
Yeah.
But these days, you don't think about voice at all.
Right.
Communications is an entirely different thing. You're still communicating. It's video, it's audio, it's text, it's WhatsApp, it's chats, it's TikTok. But all of those are under the umbrella of communications.
Right.
Which,
Right.
and if you think about all of the changes that have happened, those are pivots. Those businesses, the businesses that serve us, have changed over the last 30 years, right?
For sure. Well, let's dive in. Tell us first about Aira Networks. What are you guys doing? How long have you been around? How did you come to what was the purpose in your founding of the company?
So Aira Technologies is a venture-funded startup. We formed the company with a single vision, and that's this. There's an enormous amount of data that's resident in the radio access networks, the backbone, if you will, of the cellular infrastructure, right? And that data is not being fully tapped into. Perhaps somewhere between 1% and 5% of that data is actually being utilized to drive further improvements in the stack, in the communications. And our view was you could apply machine learning and AI to actually mine insights from that data, apply those insights to improve the functionality of the telco networks, and thereby improve performance. Right. Now you might be wondering, why does that matter, right? Well, for the simple reason that today our cellular networks probably connect on the order of about billions of connections. And in terms of, it's basically people getting connected to people. That's largely what these communications networks have been able to do. That number is moving from billions to trillions, right? Now you might be wondering, how? There aren't trillion people on the planet. Right, there aren't. But there are things, and there are way more things than there are people. And those things are getting connected to things, and those things are getting connected to people, right? And so there's a paradigm shift occurring, to your point, a pivot occurring, where the telco organizations have to learn to scale, do more with effectively what they have, dramatically more, because that's about an order or two of magnitude different when you go from billions to trillions.
Right.
And the only way you can do that is by taking advantage of all the insight that is there in the network, but you're not taking advantage of it today. And that's where AI and ML comes in.
So
and Aira is focused on effectively enabling that transformation to an AI ML world of telco to occur. Right.
Well, before we get into that, let's just actually take a step back and talk about RAN itself. It's maybe something that people who aren't very involved in the telecoms industry are unfamiliar with. So give us a bit of background on what is RAN.
So RAN basically stands for radio access network, right? So every time my cell phone is constantly pinging the base station. Base station is being pinged by all of our phones, all of our devices. That base station is part of the RAN. The radios that you see on towers around Barcelona or whichever city you happen to be in, those radios are part of the RAN, right? So the way this works is the signal from my phone goes to the radio intercepts the signal, it's connected to a baseband of some sort.
Right.
And baseband then converts the signals into some form of a message. That message then gets sent back to the consumer wherever it was intended to be. That whole backbone is what is called the RAN, the Radio Access Network, right?
I see.
Typically a telecommunications provider, about, I would say, 60% of their energy on an annualized basis probably is going into the RAN, what's the backbone of the network. About 40% is going in from what you might think of as traditional IT and things like that. But about 60% of the energy that's consumed in a telecom operator is going into the RAN. Does that help?
That does help. And I think in terms of the RAN itself then, and the technical evolution within RAN, just say a little bit about that, because it seems to me that it's heading in the same direction as cloud, when cloud created software-driven infrastructures and software-driven pipelines.
It very much is, but it's not moving, I would say, as fast as perhaps the cloud did, right? So cloud didn't occur overnight, right?
Yeah.
Cloud effectively is, if you think about it, is modern infrastructure computing, right? Before cloud existed, you thought of it as servers, right? Client server, right? Client being a PC or something,
Indeed.
right?
Yeah.
Before client servers, it was a mainframe.
Exactly.
Right?
The epochs are coming out,
that
epoch
is
1 and 2. Yeah, we talk about this
literally
on
the way we
show.
describe cloud.
Okay.
Exactly.
Mainframe,
like
client server, cloud native.
You do talk
the
about
three
it.
epochs. Yeah,
All right.
the three
Literally
epochs.
see it like that.
Now, if you think about mainframe and time frame, right? Mainframes were highly vertically organized, right? Meaning you could buy a mainframe from IBM, you could buy a mainframe from Digital, right? And if you wanted to buy a database management application, which was a lot of what people did in those days, right? You can get it from IBM, right? But you cannot take the database management system from IBM and run it on Digital, right?
Right.
Yeah.
Interoperability was taboo, right? Not even it didn't happen, it was taboo,
Yeah.
right?
Yeah.
And that world went from being highly vertically integrated to horizontal, right? And when it became horizontal, you could interoperate. An entire software industry blossomed on top of that, and all of that software can run on anybody's server, right? Not just on one particular vendor server, right? And that went from there to cloud, if you will, right? Cloud is to some degree a verticalization of to some degree, but built on horizontal components, right? Now, if I contrast that to the RAN, right? And you talked about the three epochs, right? Mainframe, client server, and then cloud.
Yeah.
If I compare those three epochs to the RAN is still stuck in the mainframe era.
Right, okay.
It's highly vertical, right? You can buy radio access equipment from Ericsson, or you can buy it from Nokia, right? But if you wanted to interoperate between the two, good luck.
Yeah.
Right.
Is it a challenge? Subtly.
Sounds like a market opportunity.
It does.
Challenge is putting it mildly.
Okay.
Right? So, but there's this very strong desire to move from that verticalized world to a disaggregated world, right?
Yeah.
And the motivations occur for several reasons. One, when you go from billions to trillions of connections, you need to be able to innovate much faster than what has happened, right? And that innovation can only be facilitated via a disaggregated world. I talked earlier about the applicability of AI and machine learning to really improve the performance of the network. To be able to do that, the experts in AI and ML aren't going to be coming from 3 companies. They're going to be coming from hundreds of companies all over the globe, much the same way the software world evolved between client-server and cloud computing. To be able to tap into those hundreds of companies, of which, by the way, Aira is one, to be able to tap into those, you have to have a disaggregated, open RAN network, so you can actually tap into that innovation that's occurring outside of the walls of 3 or 4 corporations.
And we talk a lot in core software as loosely coupled but highly cohesive, and it feels like this is the same thing where at runtime everything can interoperate through codified structures that can be updated in real time, as opposed to having this clunky plug it in, get somebody else's software.
That's exactly correct. It's happened already in cloud. And if you go back to the 3 epochs, right? If you were living in Epoch 1, or if you found a person from Epoch 1, they would not be able to visualize Epoch 3, right? But Epoch 3 exists, right? So can it happen in RAN? Yes. Is it going to be hard work and will it take time? Yes.
Do you think do you think the lessons learned in the 3 epochs of main compute will allow some form of leapfrogging to go on in the RAN world?
It should, right? Because the lessons that did occur from mainframes to client server and cloud, there are direct lessons that apply in the RAN domain. So it should.
So let's then talk about what you guys are trying to do to leverage AI and AI-enabled thinking to impact the performance of RAN and I guess to mine data from it to do interesting stuff. So tell us a little bit about that. How do you foresee that being something that ultimately is useful and improves performance?
So best way to do this, Dave, is by giving you an example or two, right? So I'll give you 2 examples, right? Example 1, your base stations, for example, that I said your phone's connected, right? We're connected to a base station here, probably something not too far away from the campus here, right? That we're all in this trade show. And the demographics that base station has right now is going to represent that this is an extraordinarily busy conference, probably some 80,000 people, right? All interacting with that. And that creates a dense environment, lots of interference, etc., right? That has a unique personality, right? And that personality can be understood by that base station, right? Now let's talk about a base station that maybe right at this point in time is sitting in city of Barcelona, right? And let's take for another example, maybe a base station that's sitting in the wine country of Priorat, right? And the demographics and the personality of the 3 base stations I described are going to be completely different because of the geography that they're in, because of the people and the density that they're in, etc., right? But yet, the software running on those base stations, the algorithms that are run on those base stations are pretty much exactly the same, right? Well, with machine learning, right, and AI, each base station's personality can be identified, right? It takes a few seconds, if you will, or minutes, but the machine learning blocks in a base station could recognize, I'm sitting close to MWC, which is very popular, and looks like there's a lot of interference occurring here. I don't need to use my standard algorithms, I need to use something different. Equally, the base station sitting in Priorat could recognize I'm in, it won't know it's a vineyard, but it will know it's the day spreads and the signal to noise ratio, all of those will be different, which will tell it I'm in somewhat of a rural area, right? And that should have a very different personality from an algorithm standpoint. That's recognizable, right? AI is actually extraordinarily good at classifying the kind of environments, right? You can then use that classification to drive the selection of algorithms, and that then drives the improvement in the performance, right? So we've actually done that. And we have a demo right now running in one of the booths here, where we're able to show that if you can actually do that detection, you can improve spectral efficiency or throughput by a factor of 2x, right? That's not trivial, right?
So as a consumer, does that mean that basically my phone's going to run faster?
It's 2 things. If you're like watching video and so on and so forth, your video will be much cleaner. That's one thing. The other thing it will mean is on the edge of the network, right? Your signal is not going to get dropped. And your edge, the other way, your edge moves out, right? Because you might have a radio radius of, let's say 100 is short. Let's say the radius is 1 kilometer. Well, if you're able to improve spectral efficiency, your radius is going to improve way more than that.
So you get better quality of service.
You get better quality of service for a much longer distance, right? So that's one example, right? Another example of using a machine learning and in a RAN environment is I'll use a very buzzy term, generative AI and large language models, right? So generative AI or large language models are extraordinarily good at 2 things. They're really good at generating code, right? And they're really good at defining intent. If you can ask it a question in English, it'll intuit from your question what you actually want it to do. That intent it can discover, right? What you can do, and this is another thing that we have done, right, is we put a wrapper around a large language model, and the wrapper that we put around it is telco knowledge, telco expertise, and then we use, for example, we enable imagine you're a network expert or network operator expert, but you're likely not a programmer, right? But you're trying to get information out of the network that helps you do your job, which is troubleshoot where is the most traffic occurring on my base stations, and can I shift some of that traffic from base station here to base station here, right? And that information, to get at that, is not the easiest thing to do, right? Well, with say what we're talking about, we call this product RAN GPT.
Right.
With RAN GPT, you can simply ask the question in English, saying, what's the performance of my network, and which area of my network is the most congested? And by the way, can I alleviate it by shifting the traffic elsewhere?
Right.
Using simple English, and you can get to the answers.
And that increase in accessibility to the information is pivotal in creating the curiosity that somebody might continue querying, get further and further, and then the ever-increasing optimization and efficiency can be configured in. And it's just about, you almost cut the middle person out to convert the technical to the meaning. It does it for you, which is...
Well, yes, eventually that could happen. Our view is it makes the experts in the middle a lot smarter, and shrinks the time for them to do some of the... You just described an iterative process, right? And that iterative process could lend towards developing or providing a set of code, right, that you can run not just once, but multiple times when that scenario occurs, right? So in the scenario I'm describing, we're basically saying you just have an assistant that helps you, makes your job a lot easier, potentially a lot more enjoyable.
Yeah,
right?
absolutely.
And
You take the heavy lifting out and you make it much more about the detail that's important.
Yes.
Yeah.
Which of course is another development that it shares with the world of cloud, and how generative AI is being leveraged in cloud to do basically natural language execution.
Exactly, right? So what this is a natural language interface to your telco RAN, right? And basically, where before you needed two distinct sets of populations, a network expert that knew the network and a programming expert that knew programming, and to be able to get to the solution, RAN GPT combines the two into one, right? And now you can think of it as this is the assisted brain for either the network expert or for the coder.
So what
choose.
What is interesting in that, though, is you talk about still being a little bit in the mainframe era, but you're using concepts and technology from Epoch 3 and applying it back to Epoch 1, which will accelerate the pathway through, won't it? So you have learned, because you are essentially applying new understanding.
Exactly right. The analogy I use often is, if I were Gulliver and went to sleep 40 years ago, which is about the time modern cellular communications came into being, and then I happened to wake up today, or this era, right? But magically all my communications theory knowledge that I had in my head stayed in my head during the time I was asleep, and then I woke up and all of a sudden I became a cloud expert. You would do the RAN in a modern way, using AI and ML, rather than the way it's being done, right? So...
Well, fantastic. Well, look, thanks for sharing that with us this afternoon, Anand. I mean, a fascinating insight into what is going to have to go on within network infrastructures to be able to support the level of growth in radical increase of devices on networks.
That's correct.
Thank you so much for your time.
Thanks for having me. I hope this was fun.
It was good.
It was great. Now, we end every episode of this podcast by asking our guests what they're excited about doing next, and particularly given we're at a conference, what you're excited about doing next in MWC.
Well, for us, it's basically seeing our babies come to life. The babies that we've been working on for the last several years,
It's
developing.
like graduation.
It's kind of like graduation,
right.
and you want to see these babies go into the real world and grow up. So for us, that's what we're looking forward to.
Well, wonderful. We wish you the best of luck with that.
Thank you very much. Thanks for having me.
So a huge thanks to our guests, Muneyb and Anand. Thank you so much for being on the show. Thanks also to our sound and editing wizards Ben and Louie, our producer Marcel, and of course to all of our listeners. We're on LinkedIn and X, Dave Chapman, Rob Kernahan and Sjoukje and Rob. Feel free to follow or connect with us, and please get in touch if you have any comments or ideas for the show. And of course, if you haven't already done that, rate and subscribe to our podcast. See you back in the MWC reality soon.